So, a few things occurred to me, but something in particular, showing the zero thing, the zero to various powers. It might seem that there is a sort of handedness or chirality or asymmetry um, in what's going on there, because when you look at, say, like this, oops, you get zero, and then what I'm claiming is that this is reasonably zero, and this is reasonably also zero. To the point that I think you should probably just assume that these are zero unless you have evidence otherwise. But this is this. So doesn't it appear that this is actually favoring this dimension, right? So these are all what these are. These are units in different dimensions, right? And because 0 is this very special value that is at the intersection of every possible dimension at once, the way that it behaves in one dimension should be the way it behaves in all dimensions, right? But this appears to be an asymmetry to that, right? This appears to be a violation of that relativity principle, right? So the idea here that I'm suggesting is that you can whatever you choose as your real dimension, as your real number line, is arbitrary, right? So you could choose what we're here saying as I as to be your real dimension. In which case, this clearly it should be zero, right? Or you could just reverse polarity, and this should be zero, right? But that hints at what's going on here. This one and this one really are not the same thing. This is a positive one. This is a dimensionless one. This is a bare number one, right? This has a unit, it has a dimension, and its dimension is positive. This has a unit, it has a dimension, its dimension is negative. This has a dimension, its dimension is I, right? So this actually isn't a problem. um, yeah. There is no, in terms of just numbers, there is no negative one. There is no positive one. This is just one. That's it. That's all it is. It's just one. This is not just one. It's positive one. Just like this is not just one. It's negative one. And this is not just one. It's one I. Right? I'm not sure how much I need to explain this. But since it's not a concept built into conventional mathematics, I'm fairly sure I need to explain it somewhat. So yeah, I don't know. I don't know if that clarifies anything for people or not. But like basically like you have your number line here. There's 0. And then it goes this way. Boom. Right? And say this is right here we get positive 1. Oops. Let's do, there's -1 right there. Right. But relative to that number line, whoops, sometimes I can type. Relative to that number line, 1 itself is just over here somewhere, and like 5, and over here we have 2, and like these guys are not on a line, right? These guys do not make up a dimension. Okay, these are just numbers. These are numbers. These are values on a dimension. Let's shorten this up so it doesn't look so stupid. There we go. Right, so this will go to like positive infinity, and this will be negative infinity out here. And then like I would be over here somewhere, right? So this goes up a little ways. But don't be confused and think that these are on the plane here, right? These are not. They're not on the plane. So I could be smart about this. Right, so these numbers over here, um, they're not a dimension. They're not one of these things. Right? They don't have a unit. They're not organized in that way. And that's fundamentally why 1 plus 1 doesn't even make sense. Right? Because this is how the numbers are just fucking randomly, like, yeah, 1 describes this sort of thing. It's a name for a type of a category. 2 is a name for a type of a category. There's sort of a sequence-ish in there, but it's very artificial and contrived. It's nah. It's not operating like this up here. It's not in a plane. So when 0 to the 0 is this guy. 0 to the positive 1 is this guy. 0 to the negative 1 is this guy. 0 to the 1i is this guy. 0 to the 1j. 0 to the 1 elephant. Whatever. It's this. Right? 0 to anything other than 0 is this. 0 to 0 pops out just the bare number 1. Right? That is, it does not lie on a dimension. It does not have a sign. It's not positive 1. It's not that we're favoring this dimension somehow. We're not. It's a totally different thing from that. The confusion comes purely from conventional orthography, which is broken. Even in conventional terms, it's broken because there isn't really a nice way to clarify in casually when you're dealing with a vector 1 or a scalar 1 without indicating a bunch of extra shit. There are ways, but they're sort of awkward. And they're awkward enough that we just don't do it, generally. For the most part. Like, things are obfuscated, right? Like, this is that an operation or is it a sign, right? So like if we're dealing with something like 7 plus 3, is this an operation or is this just a list? Right? Which way is this being notated? Like, which way is this being thought of? What is actually happening here? So this is conventional, but this is like what it actually means. What it actually means is you have a list of +7 and +3. And when we go through that list in full, we get +10. Conventionally, we pretend that this positive symbol is an operation. But when we actually do it, we don't treat it that way. We treat it this way. Except we're dishonest about it and we don't admit that we treat it that way. But as soon as it becomes a negative, right? So 7 minus 3. Watch what happens here. I can flip this around and we get -3 plus 7. So suddenly, this thing that was an operation over here becomes just a sign. And now it's far less weird for me to just look at it this way. So over here, we're treating this as an operation, and we're treating bear 7, or what we're writing as bear 7. When we move it, it has to become +7. Right? So these are faults with the orthography, and they do trickle down into the philosophy, I think. And basically, I think this is a lot of the core problem that's occurring here, right? So you look at this, and this might appear naively to be biased towards your real numbers, right? Because you think of 1 as a real number. You're taught to think of that way, but it isn't. It isn't. When you think about all of this rigorously, that's impossible, and you end up with weird paradoxes when you try to think of it that way. But when you stop thinking about it that way and you think about it more correctly, more rigorously, those paradoxes dissolve. So, yeah, I think these are some things that should be brought into mathematics in general, and they're just not there.